When you're running AI programs, we often think of the limitations in computing power. But as well as computing, we also have to consider the bottleneck that is moving data in between chips on a board, or otherwise known as fabric. IPXers, we're at the Baya Systems booth at Embedded World 2026 to have a chat with them about their scalable fabric IP. Nandan, great to meet you.
Nice to meet you, Adam.
What do you do at Baya Systems?
So I'm the Chief Commercial Officer of Baya Systems, which basically means I've managed all the operations as of engineering, product, marketing, business development, sales, ecosystem alignment, and strategic partnerships.
Awesome. So in the modern world of sort of AI computing demands, what we're finding is that it's not just the raw compute power that's becoming a bottleneck, but it's also the movement of data in between chips that is becoming a limitation. Could you expand on why that is a limitation, and also what are some of the difficulties with current architectures in handling that?
Absolutely. So if you think about AI is all about data, right? And how you compute that data. The size of that data is getting enormous, and the ways to compute it efficiently are also getting very diverse. As models change, you realize that different types of compute connected to other different types of compute are necessary to make all of this happen. Right? If you go back 10 years, most of the AI software algorithms were run on CPUs, right? Data centers were CPU centric. Over the last 10 years, the GPUs took over because data is also about wide matrix manipulations and large sets of data going through that. But also as models have evolved, as software has evolved, you start realizing that in order to deliver on the promise of AI, it needs to be a lot more efficient and at the same time a lot more performant. That means different types of compute elements need to be orchestrated to do what is needed in the time and the power and the cost budgets you have. And that can't happen without very efficient, very capable data movement to and from memory, to and from units, and across multiple dies, across multiple chips, across multiple racks, across multiple computers.
And for that, we need something that isn't quite covered by current architectures. So at Baya, what do you do differently that helps to enable that future?
Right, so we play a small part, you would say, in the entire ecosystem. And if you think about data movement at nanometer scale down to millimeter scale, we play in that space, which is kind of with on die and across multiple die in system on packages. And then of course, once you go out so that you go to meter scale, which is really racks, and then kilometer scale across data center. But we focus on this part. What's happening is each type of compute element needs to be handled, delivered data at a certain level in a certain way. But if you do it piecemeal and at component level, it doesn't work. You have to understand the whole workload, what's running on the system, and then design your data movement to support all of that. And so Baya, which is now effectively a third generation, considering the founders have started a company called NetSpeed about 15 years ago that got acquired by Intel. They spent time at Intel understanding data center challenges and then came out and started Baya. We go software-driven fabric generation, data-driven analysis and optimization. So by thinking software first, understanding what kind of workloads you're designing for, you can actually build the fabrics that are suitable for it, more efficient for it. By thinking about hardware implementation challenges first, by actually having a transport that can support these different types of computation, different types of protocols, by having a design that understands and comprehends how to implement it faster and easily, and a mechanism that allows you to also build with chiplets in mind. That's what's needed for this next generation of compute structures for AI.
And so thinking of this software-driven approach, if I'm an engineer and I want to use Baya's fabric IP to take a POC to production, what does that sort of workflow look like?
So that's an excellent question, because effectively you start from up here thinking this is my concept, right? And I say, what should my memory architecture look like? What should my cluster architecture look like given these workloads, right? And you understand where your bottlenecks are, what is closer components, what are harder components, and you can actually do the architectural support for that. Once you've defined that, once you've defined your partitions, you've defined, then you can actually build out your actual fabric structure microarchitectures. Okay. And then once you've done that, you build it in a implementation aware fashion, physically aware fashion. And then once you've gone to silicon, you should still be able to tweak and tune it. So Baya's software workflow gives you a chance to go from conceptual architecture to microarchitecture development to physical deployment, and then post-silicon tuning.
So Nandan, tell me, aside from AI, what are some really good applications of your fabric IP?
That's a great question. So when I look at, we talked about end-to-end platform design, which is data-driven, and yes, AI, when you think about AI, there are different types of workloads, et cetera, but that translates to other markets as well. What is fundamental to all of this is that we design our IP that the software puts together with a common transport architecture that allows different types of protocols to come in, right? So you can actually go into a data center setup where it's CPU centric and have large coherent cluster cores, right? You can go into effectively an automotive type environment, which is again, very wide and more data driven or data bandwidth driven, right? But then it needs functional safety features. You can go into edge AI, whether it's IoT effectively, but network edge, where again, the requirements are different from a workload standpoint, cost profile standpoint, efficiency standpoint. And then of course, where it's really becoming interesting is all of this has to be connected together at the main, through the main network. So the infrastructure, right? Wireless infrastructure, wired infrastructure that connects all these things together to make the formal cloud, as well as in data centers, you look at scale up and scale out switching. We're actually seeing those are the markets that are really taking up our IP. And especially if you look at switching in data centers, scale up and scale out, our product called NeuraScale, which is really a unique offering that we have, enables these high radix switching solutions that can push scale up capabilities much higher node counts, higher bandwidth, without compromising on latency, and at the same time constantly reducing effectively what you need for tokens per watt.
And so sort of to that point, I've heard Baya has announced their partnership with a bunch of different companies to form this sort of ecosystem. Could you touch upon some of the companies that you partnered with?
Absolutely. So we are an IP provider, right? And effectively, IP provider is only as good as the ecosystem that surrounds it, the partners that surround it. If you go back a year and a half, we first announced our partnership with Tens Torrent, which was actually doing AI chips and RISC-V IP that we are working with. We're building chips with our fabric in it. Last year at Embedded World, we talked about semi-dynamics. Now we're also partners to all the key capabilities around the Open Compute Project, UCIe, Ultra Ethernet, all of those are partners. But a number of RISC-V vendors as well, like Andes and Sci-Fi, MIPS, etc. But really what we expanded this year and what we're announcing this time is our partnerships with Synopsys, where Baya tooling is becoming part of or plugging into the platform architect, which you'll hear more about. We partnered with AION, which is a company that does effectively implementation services, architecture, all the way turnkey. And we become a real component that helps them design systems and implement systems much faster and deploy them. And then of course, the
big dogs, ARM.
Exactly, ARM. And with ARM, effectively, we've been a part of the ASPA, which is their partnership around the AMBA system, which is of course an open standard, but still ARM compliance is a very part of it, or AMBA compliance means ARM compliance. So that's the third big partner that we're actually showcasing this year.
Awesome. Nandan, if I'm an engineer and I'd like to get started designing with your fabric IP, what's the best next step? How can I get started?
So very simply, just go to bayasystems.com or bayasystems.ai, look at what we have, contact us, set up a demo. It's very easy to do. And then once that demo is done, once you get a sense of that, we can set up evaluations. So we have a very simple process to get up evaluation started. And we've onboarded customers in a matter of days or weeks, and people have had their first design cycles in, again, days or weeks, because it gets you really close to your target configuration, and then you're tweaking and tuning, but really takes the guesswork out at the beginning rather than having to trickle it down towards the end.
Awesome. Nanan, great to meet you and great to chat about Baya Systems.
Pleasure.
This is Baya Systems at Embedded World 2026. They've got exciting things that they've announced. If you want to find out more information, you can find them in the links in the description below. And as always, at ipXchange, stay disruptive.